This video is to walk you through how to use Cura slicing software to import a 3D model and to send that model over to the Ultimaker S3 printer for 3D printing. So on the lab computer, you'll open up the Cura software. So what you're seeing here is just the opening screen. We don't have any part or object yet. So what we need to do is go to File, and then we can go to Open File, and where we can go is in the, let's see here, we can go to the Fahrenkrug Lab Active Data page, 3D printer files. This is where I recommend saving all of your 3D printer files just for easy access. We'll pull up this dual beam spectrophotometer and say we want to print this dual spec base. So if we open this part up, this is what we'll see immediately. So this is the object, and it's going to automatically center that object within the build plate. You can see this error, model errors. Your model is not manifold. The highlighted areas indicate either missing or extraneous surfaces. That's perfectly fine. What that means is whoever constructed this file using 3D CAD software like SolidWorks has intersecting planes in the model, and the actual STL file, which we uploaded, and that's the file format that's required in order to upload into Ultimaker Cura. Those intersecting planes are poorly defined, and so the model doesn't always know where to slice this thing. That's perfectly fine. This will work. So I'm just going to close that out. Notice right now I have this panel to the left, and it's all grayed out. That's because I haven't selected my model. There's two ways for me to select the model. I can either click it in physical space, or I can click down here under Object List, and I can find the object that I'm interested in selecting, which in this case there's only one part. You should know that you can add more than one part, so I could say I want to open maybe two files and actually print two of these bases simultaneously, and you'll see that it will be added on top of or in addition to. I'm going to click that one and delete it just so that we can simplify things, but if you do, for efficiency's sake, require printing more than one object, feel free to do that. Another mechanism that's useful is if you're printing, maybe you have small parts and you want to print a bunch of them, you can, and I'll just delete this to show you, so I can open file and maybe I want to print, say, this case mount. It's this small file. If I want to click this and say I want to print 10 of them, or maybe I just want to print 4, I can right click on the object, click multiply selected model, and then maybe I'll have 3 copies for a total of 4 objects, and it will automatically distribute those in an efficient manner. So I can click those in the object list, hold shift, click all those and delete them, and then I'll open up the original base that I wanted to talk about. Okay, so how do you navigate in this thing? Well, I mentioned if you click the object, you're presented with a whole bunch of different options here. If you click the object and then hold right click and move, while holding down on the right mouse click, you can rotate your object in space. If you use the scroll wheel, if you scroll forward, you'll zoom in. If you scroll backward, you'll zoom out. So that'll allow you to inspect this model as you need to. So a couple things. Before you think about slicing this model, it may not be the right size, it may not be in the right position for you, depending on the object. A lot of times if you didn't design the file, or even if you did, it may be imported into Cura in a way that maybe isn't the most efficient for printing. So you really want to think about things like where it's red, that's where there's overhang. That, if you can imagine, that's where the printer head is moving and printing in space, but there's nothing below it. So there's nothing to actually build on top of. Those are high-risk areas, we call overhang areas, that can lead to sort of stringing of the filament as it sort of falls down below. So sometimes to minimize overhang, we can do things like rotate this object and print it on its side. So if you want to do that, you can go over to the manipulation set of options here, and I could click this rotate tool, which is the third one. I've got lots of different rotate options. One that I find to be really useful, especially for this task where I want to take one face, maybe I want to take this side and lay it flat, is I can click the select face to align to the build plate. So if I click that button, nothing happens, but it's going to want me to select one of the faces that I want to align. So if I click on this side, you can see that now that has flipped this in space. This in this case, usually it sets it flat, but it didn't in this case. So if we need to move this object, we can click the Move tab, and then you can see that the Z height here is 25 millimeters above the build plate. So I can set this to 0 and drop that back down so that it's flat. Okay. So I'm going to undo these two options because this is a perfectly reasonable way to print this. But notice if I'm in the Move pane here, I can click on this object, I can move it around in space, or I can change these values numerically by just typing into these options here. Another useful tool is scaling. So sometimes if you are printing a model, or maybe you downloaded a model from somewhere and you don't necessarily need it to be the exact size that it manifests as, you can say, oh, actually I want to print this at half its size. If I click 50 here and I enable this uniform scaling option, it's going to scale X, Y, and Z simultaneously as 50. So if I press enter, you can see all of these change to 50% scaling, and then we get a smaller object. So I'll undo that. Rotate, self-explanatory. Mirror is if you have an object, a three-dimensional object, and you want to mirror it across a particular plane, so you can do that. And then per model settings here, you can choose certain areas of your model to print it as a normal, using the normal filament, or you can use and print that section as support. This is a little bit more advanced, and we're not going to cover this in this video. Okay, so once you've sort of gotten your object where you want it, and you've scaled it appropriately, rotated it appropriately, now you need to change the settings for how it's actually going to print. Because so far we haven't really discussed exactly how this thing is going to print. So the Ultimaker S3 actually has two extruders. You can see those two listed up here. So if I click this, you'll see the extruder 1 has material right now. It's loaded this PLA, black PLA, and it's on this 0.4 millimeter print core. And then over here we've got print core 2, which is called BB 0.4. It's also a 0.4 millimeter print core, and on that spool we have a natural PVA, or polyvinyl alcohol. This is the stuff that dissolves in water, and the way that this is set up currently, it may not be set up this way when you're using it, is that you could print your PLA, which does not dissolve in water, with PVA as support material. So if you have really large overhang areas that you feel are going to print really poorly, then you could add support to this model, and then after you're done with the model, you'll be left with a whole bunch of PVA in certain areas. You can toss the whole model in water and then dissolve that away. Okay, so these should automatically load, so you shouldn't have to change these at all, just showing you what they mean. What we do need to change is this function over here. So if you click this button, actually what you'll find the default to be are a really limited number of settings that you can change. You always want to go to custom settings here, and then you'll be presented with all the slicing options and printing options for that particular model and that particular print head. So right now we're selected on 1, not on 2. So if we select 1, that will tell us all of the things that we need relevant to printing the tough black PLA material. So often, if you're downloading a model, you can find comments. If you're going to Thingiverse and you download a model, you can look in the comments section or the description of the build, and there'll be often recommended settings for printing. The layer height here, actually, and I should just say, if you hover over the entity, it'll give you a really quick summary of what that is. The layer height's one of the most crucial things in printing. That's physically the height of each layer, each pass as you're building this model. So 0.1 millimeters is 100 microns, so that's pretty high resolution. It's considered fine resolution. This machine can go all the way down to 0.06 or 60 microns, which is really, really fine detail. But as you can imagine, the thinner your layer height, the more passes are required, and you exponentially increase the print time for the object. So it's always a trade-off between sort of the surface finish and the quality of the print versus how long you really want it to run. So this object I've printed many times, and it does well at 0.3. You can see the lines as it prints, but it doesn't deter its functionality at all. The shell here is when you're printing an object, most often the majority of the interior space inside of what appears to be solid is actually void space. So that you don't waste a bunch of material. But the outer few layers are printed completely so that you get this outer finish that looks like it's 100% filled. That's what we call the shell. And so here you define how thick you want that shell to be, which in this case, the wall thickness, how thick you want that to be. This is 1.2 millimeters. Maybe I only need a half a millimeter for that. The wall line count then is going to be a function of this value. So if I set this to 0.6, you can see that if I'm having a layer, each layer is 0.3 millimeters, and I need the outer shell of this thing to be 0.6, that means 2 passes will constitute the entire wall of this object. So the same is true for the top and bottom. So if I have a top and a bottom, how thick do I want those to be complete? Infill is another really important thing. This is exactly what I was mentioning before. How dense do you want the interior of the solid object? If you set this to 100%, what that means is the entire interior volume of this object will be completely filled with PLA. Most of the time that's completely unnecessary unless you're building an object that requires a lot of rigidity for some sort of functionality. This particular print does well at about 15%, which means that only 15% of this object is composed of PLA. It looks like it's solid because of the outer shell, but the interior is only 15% filled. So infill density often around 15–20% is pretty good for objects like this, unless you need a higher infill density for its functional purpose. The pattern of the infill describes of that 15%, how is the material being oriented within that volume? There's a lot of different things that you can choose here. I often use gyroid. That gives a pretty good rigidity of the structure in all 3 axes, but there's different reasons to choose different ones. When in doubt, gyroid's a fine one, but if you want to do a little bit of research, you can feel free to change this up. It won't really change significantly the overall build time. Printing temperature and build plate temperature, these values will be default entered based on whatever material the printer recognizes. So in this case, it knows that it's using PLA, so it's going to punch in its values of 210 for the print core, that's the actual extruder temperature, and then the build plate, the actual glass plate below it at 60. There are reasons why you may need to change these, but the printer will always give you the default for what it thinks it should be using for that material. There are a variety of different issues you may encounter with different parts that may require fine tuning and tweaking here, but that's beyond the scope of this video. Print speed is another really important factor. This is a direct function of how long the print's going to take you, but as you can imagine, as you are printing, say, a overhang like this, if you're going from this top post to this top post in space and there's nothing below it, the faster you move, then the easier it is for that PLA to droop in that overhang. If you print really, really slow, it's going to solidify by the time the print head moves over. And so this is a strong sort of contender for dictating how much overhang you get in your print jobs. The slower the speed, the better quality of the print, but the longer it's going to take you. So often you want to do a test print, and you want to get this as fast as you can that isn't going to compromise your model. 45, actually I can run this up to 60 in this model. You will see absolutely drooping here, but it has no impact on the functionality of this device. So I usually run this at 60. Travel, enable retraction means that when the extruder head is moving, it can pull up and out of the way. I keep both of these selected. Cooling is another one that I always keep selected, and I keep at 100%. Cooling helps to sort of allow you to print at a faster speed. So in the print head, as it's printing, there's a fan, and that thing's running at 100%. And again, as you imagine, this thing is moving across here and printing this overhang section. If you've got a fan blasting on the filament, then it quickly solidifies before it can start to droop. And so you're cooling in real time. You want to be a little bit careful because sometimes with certain materials, PLA is pretty good like this, but certain materials, if you cool it too much, then it's going to start to stick to the print head and it won't actually make it to your model, and you'll just get a bunch of gunk or buildup on the tip of the print core. And so for other materials like ABS, these things will change. PLA is pretty forgiving. Generate support, this is a really important one. If you click this, then it significantly increases the time to printing, because then it, if I click this, you'll see it's going to ask you what extruder you want to use. And then in this case, we'd want to use extruder 2 because that's where the PVA is. And it's going to support placement everywhere on your model where there's an overhang of 45 degrees or greater. So in this case, this overhang here is straight up 90-degree overhang. But even for sloped regions, it's going to generate this support. And so when you go to slice this model, you'll see that a whole bunch of support is going to get generated in all of these orifices, and it's going to double my print time. This print right now is about 13 hours. If I have this, it'll take roughly a day, maybe a day and a half. I've found out that I don't need this. I often recommend setting up a print job and testing whether or not you need it. And if you don't need it, it's going to be faster and better. So I'm going to deselect that. Build plate adhesion talks about or refers to how the model ultimately is going to stick to the build plate. I always enable a print blob. What that does is it sort of primes the extruder before it ever starts printing your model. So after it does its bed leveling routine, it's going to then move the extruder over into this front corner, and it's going to dispense a whole blob of filament. The purpose for that is to ensure that there's actual filament in the print core. If there's not, if for whatever reason it's been retracted slightly, or it's not coming out or not dispensing, as it starts to print your first layer, that first layer is super critical, because if it messes up and you get a defect in the first layer, then that can ruin the entire print. And so just by dispensing a little bit, it's a little bit wasteful, but pretty trivial in the grand scheme of things. So I always leave this clicked for PLA. Build type or build plate adhesion type refers to whether you're going to do any extra work to try to get this model to stick. There's really 4 different options. You can do none. This model, we wouldn't actually need any. Skirt will run one little line around the periphery or the perimeter of whatever the object is, and really that serves to be like an extra prime blob, because it's not actually connected to your model at all. Brim is a single layer attached to the model beneath it, and raft is a thicker layer. So if you've got objects that are maybe really precariously perched, like a really tall, thin model that could easily fall over if it weren't rigorously attached to the build plate, then you're going to want to move up to the more rigorous type of adhesion to the build plate, like a raft. So raft is the most intense, brim is sort of a medium, skirt is the least, and none is obviously there's no adhesion addition at all. Okay, so that's all we need to modify here. So once you do that, you can close this out and click slice. And what that's going to do is it's going to convert this 3-dimensional model into a bunch of printable layers, which essentially transcribes that to G code. So I've got this running pretty fast, so this is an 8-hour print at this point. At this point, you can, I'm on my office computer, so you're not seeing the exact function here. You'll get an option that says print over network, because that computer in the lab is directly connected to the 3D printer. So you can click send to printer over network, and that's just going to send the job, and then it will just already start. You want to make sure at that point, though, you've already added glue and cleaned up the print base. because once you send it over, it's going to automatically start. It's not going to allow you to release the job like a laser cutter will. It's going to just start through the routine. So if you've got something on the build plate, it's gonna fail your print. Okay, so there is our model. Now that it's sliced, I can go to preview. If I go to preview, you can see my this is the actual model, or what it might look like. And what I can do is look on the far right here. These are all the individual layers. So there's 368 individual layers, all at 0.3 millimeter in step. So I can sort of move through the entire set of layers, and I can actually simulate where the print head will be at any given time. So I could, for that layer, I can see where my print head is if I drag this through. So I'll pull this back up. Under view type, I'm given two options, layer view and then x-ray view. X-ray view is nice if you've got a bunch of embedded features that you can't see in the solid model or the layer view, and so if you want to see how those look. I don't find a ton of tremendous utility in this, but it might be useful for you for various reasons. So once you're pretty satisfied with this, then you can send this off, and you'll be good to go. At that point, you can click the monitor function. In the lab computer, you'll see the actual printer. There'll be a small camera icon. You can click that camera, and you'll engage the webcam that's built into the Ultimaker 3D printer, and you'll be able to watch the print in real time. So that's everything.